I wrote a function myself. So I will explain it. I will explain the Matlab existing functions first. In Matlab, there is a function called the residue, which can be used to find the partial fraction extension of a given transfer function or a rational function, but it is taken in numerical way, in double precision way. So sometimes it may not give a very accurate result or analytical result. So I will explain this one to you first. In the function call, we have b and a, where b is the numerator polynomial. They are the coefficients vector. And a is the denominator polynomial, also coefficient vector. Coefficient vector. And then we can find, call the residue function, we can find the r vector, p vector, and residue k. And I will demonstrate this function by an example. Suppose we have a rational function like this. We can extract the coefficients of numerators and denominator first. So for numerator, we can use 1, 2, 3, and 4 to extract the numerator coefficients in descending order of n. And also we can extract the denominator coefficients from the formula there. So if we have done this, we can easily call the residue function and get RPK results. I will explain that one to you later, what they are. So we can find the results directly. Let's check the P vector. P vector may contain errors, so they are very small, so it contain errors. So the standard value for P vector could be something like this: -3, -3, -2, -1, -1, -1. So these are the P vectors. And it will correspond to x plus 3. So this is not 1. And x plus 2 and x plus 1 cubed. Something like this. So these are the poles I've found. P are the poles. And what about the R vector? R vector is in fact the numerators in each of the poles here. So in this way we can easily express the original function into a partial fraction expansion form like this. And what is the argument R? K. K here is the empty matrix, indicating there is no other terms rather than this partial fraction terms. So in this case, we can easily find the partial fraction extension to an original rational function. But it seems that there are inaccurate results here. We expect -2.125, and we can factorize it. So we can make it a rational number, but this one itself is not a rational number. It may contain other points. It may contain other values which are considered. So using Matlab function residue, we can easily perform partial fraction expansion, but we need some time to interpret it in an easy way to memorize. Based on the same function, I write a Matlab function like this, where we can describe in a symbolic way the original rational function s. And here we have an independent variable s. We can we can easily using this Matlab code to find the partial fraction expression, small f, directly. If you are interested in, you can read this kind of program itself. If you are not interested in it, it's okay. What you need to do is to know how to code this function. That's enough. And these are the technical details in the function. And let's consider the original function again and see how can we solve the problem in an analytical way. To solve the problem, first we have to declare f as a symbolic variable, and then we can use this command to extract the g function. It is easy. We can follow the original formula and write down the commands like this. And then we can call the residual function. T is the one we specified, and S is the independent variable. And the result G1 should be the partial fraction extension of the original function. Oops. Maybe I coded here. I use this one in my code, so I cannot modify it. This part are given in the comments part, but I have to remove this part, and then if I do not save it, it is okay. Well, I have to save it. To save it into a different name. Be very careful with the code. And here. So I can code the function in the right way. So this is the first term, and the second term, third term. And we have the following terms. And it is seen that there is no other terms rather than the sixth term. So we say that K is an entity matrix. We do not have a K there. So in this way, we can easily find the partial fraction extension to a given function. And for other examples, we can easily find the same results. And I will not show too much about the Laplace transform-based analysis again.